This is the 10th session of AWS DevOps training. And in previous session, we tried to understand the concept of AWS S3 storage. And in parallel, we also try to understand the concept of Terraform. So today we have to understand a new concept of Terraform, that how we can create the modules, what is the concept of variables, how we can uh, make our infrastructure as code the dynamic so that we can do the reusability of the code. So for this purpose, I will first of all open the Visual Studio Code. And in previous session, if you remember, let me open that previous file. I used to create some Terraform stuff to give you the idea how this whole thing is working. So here we created a main.tf file, and you remember we understand all these concepts: provider, resource, data, output. We understand the syntax, and we created all these resources. Okay, so what we did, we implemented everything in within a single file. And think like if you want to give, I mean, this file is only usable for you and only for one project. If you need to make any change, you need to change in this infrastructure as code. You cannot redistribute this. So if you want to redistribute this code, you must have to use the concept of variables and modules. So I will give you the idea how does modules work, what is the benefit. So I am going to close this file, and I will open a brand new project here. Like I can say directory, I will create uh, tf module concept. Okay, just I created this random name of file, a directory, and here I just open this in the Terraform in this Visual Studio Code, and here I am inside in this directory right now, and I just created here main.tf, and and automatically the extension of Terraform understand the file and change the icon of this file to the Terraform. So we did everything in this file last time, but today I will create the modules. So how I can create the module? So to create the module, I will create the directory here, something like I can say modules. And inside this module, I will create another directory just like VPC. In this, I will create a VPC module. So in this VPC directory, I will create a new file, main.tf. Okay, so this is the module file of VPC. So each module has its own main.tf. And in this main file, if you remember in the previous session, we use the uh, resource or Terraform resource to create the AWS resources. And here I will use AWS underscore VPC, and to create the VPC we use this resource name. You can give anyone, and here the bare minimum setting, if I do, I I need to at least define the Cedar block, and now I can give here the Cedar block just like 20 20 20 0/24. But this is not the reusability of the code. I am again using the straightforward the value. So I must have to provide here some variable. I need to write here some variable. So from where that variable will come, and from where I will provide the name of the variable, and whenever you will change the value of the variable, that will be presented here, and this code will be changed for different environment. So then it will be reusable. So in this module directory under the VPC, I am going to create another file. The file name is variables.tf. Okay, and in this variable file, I have to create the variable, my self-defined variable, and I can give them any name, and then I can call those variable at different location, and I can give the values of the variable. So to create the variable, I can use the Terraform resource variable. And for example, I want to create the variable, I can say any name I can give, VPC Cedar. Okay. The inside the body of the variable, I have to give first of all the description. I would like to give description. What is this variable for? This is useful while someone is going to read your module. If you are going to distribute your module for some purpose, so I can say provide the seeder for a VPC. Okay. Then I have to give here the type, and type can be boolean if this variable is going to be true or false, and if you are going to straightforward give the IP or some any value key that can hold numeric and alphabetic, then you can straightforward use the string. And one more thing, you can use the default. Mean if this variable value is not defined by us, then what default value it will get. So I can say if value is not defined, then simply this value, use this seeder. Okay. Now in this main TF under this module, here I will use var, and you see the Terraform automatically understand there is a file in parallel to main.tf, variables.tf, and it read this file and fetch the value from this variable tf. If there are multiple variable, it will list us down all the variable. So far I just created one. So let me create just one variable, okay, just to give you the idea. So I am going to create a very bare minimum configuration. Okay, you know how many parameter you can give here in the VPC. There are a lot of things you can configure in while creating a AWS VPC resource. So I just gave the imperative one, and that is mandatory. I mean, I cannot skip this. The rest of all I can skip. Those will get the default values. Even I have not gave the name. So just let's get start with this very basic setting. And here on the root directory, this main.tf is still there, and this main.tf you can say is the root module. Okay, root module that the first main.tf file in the Terraform is known as main module. So in this main module, you must have to define the provider. What cloud provider you are going to use? I am going to use AWS, and what region it is going to hit to create the resource. So I am going to create in which US West one. Okay, US West one. So this root module main TF defines you will create the resource here. And in previous session we create the resources here, but this time I'm not going to create the resource here. This time I am going to use module keyword, and I am going to call the module, and the name of the module I can give any name, but my module is VPC, so that's why I will write here VPC. Okay, you can give any name. It's not mandatory that the module name should be same like the uh, directory name you created for the module. And here you have to define from where this module will fetch its data. So you can type here source, and here in the value you will type dot forward slash, and it will automatically read from the root directory what directory structure is there and which directories contain the main.pf, and it automatically listed down that directory. If you create here multiple directories, it will not list it down unless you are not going to create a main tf under that directory. So it automatically senses that this directory seems like it holds main tf under the module vpc, and it holds main tf and it has some stuff. So this is a module, and dot, current location. And in Linux, if you want to work at the current location, it's been dot. So wherever we are is dot, and then this is the relative path. So this setting I give, I call this module, and in this module, I simply call this module. And this module is doing this work. This module is calling this seeder block only, and this variable. And this variable is here, and its default value is set here. In this module, while you are calling this module, here you can call the variables associated with the module. So variable that I created here is seeder, VPC seeder. And here I can give the value of that seeder. For example, I want to create 10.20.30.0/24 subnet. Okay, now roll over the mouse here, and it is saying VPC seeder optional string. If it is giving you an error, just like I say as seeder underscore new, it does not, this is not a variable. Now roll over the mouse here, it is giving you the message that it is unable to find any information regarding this variable. Unexpected is not expected here. So that's why it's wrong. So just make sure you type the right value of the variable. It is giving you optional. Why it is giving you optional? Because you can leave this value too. You can leave this variable too, because there is a default value automatically set here for this variable. So let me just start with this very basic configuration. So we understand the concept, how we create this directory, main uh, main module and the module directory. So here I will open the terminal. So this is a brand new directory I created. I have not so far pulled the AWS binary, nothing is done so far. So first of all, I need to do Terraform init. Okay, I have not saved anything, so I must have to save everything. Now I will run again Terraform init, and now it's reading the root directory main tf, and it is installing module. You see, it is declaring this directory as a module. It contains some stuff, and it is downloading the HashiCorp latest version, and then we will run Terraform plan. Okay, it's done. And now if you list down here, you can see the Terraform log file created, module directory, the Terraform directory is created under this. Everything is downloaded, module, everything is downloaded. So now I will run Terraform plan. So it will create this subnet VPC with this variable value, whatever we gave it read, and simple one resource it will add. I will just do apply, and you can see here in this VPC section, so far there is no VPC. It will create a VPC here. We go here, just refresh. You can see the VPC is created. A very simple setting we did by creating a Terraform module VPC. So far, the name is also not given. So to set the name, we did in the module, what you will do, you will update the module, and the name you can do by tags, and in the scale curly bracket key and value and name is equal to, I will say the name. I can give any name, but I want to make it dynamic. So to make it dynamic, okay, it's a good idea to define the name as a variable. I will again create a new variable, and I can say VPC underscore name, and here I will say uh, the description. I can say provide the name of VPC, and then type string, and then its default value. Yes, you should set some default value if nothing is defined. I can say uh, uh, TFVPC, Terraform Virtual Private Cloud. Okay, now I have to just go to this main, and here I will in parallel to name, I will call the variable var.vpc name. You see, automatically listed everything. So this is the beauty of using Visual Studio Code and using the Terraform extension. So I have to now save all, and now I will again apply. So it will modify the existing resource, whatever you created. So it modified. You see, only one change happened. Okay, so now if we go to here, you can see the VPC ID is same, but its name is now defined. So we did this with the Terraform. We create one more variable. So this is done. Now, if I am not going to use this variable in this module, for example, I am going to skip this variable. So you can comment anything with double forward slash. It will not execute. So save, and now again apply Terraform. This time it is not going to get the value from the variable, whatever we give, but it will use the default value of the variable. The default value we gave 10, 10, 10, 10, and this time it is saying replaced, mean existing VPC is going to replace because we are going to change the entire subnet. So this time it is using the default. By this subnet is going to replace with this one, that is the default value of the variable we did in the configuration. So if I do yes, so this variable, you can see this is the default value. It is destroying the older VPC and it is creating a new VPC. And here, if I refresh, you will see this ID will change. It's totally a new ID. It's totally a new resource created with the 10 10 10 subnet. So whenever you are going to make a major change in any resources, Terraform will destroy and create the new resource. But minor changes, just like name change, will not will just do the will just apply the new setting. So here we understand the concept of module, how we can call the module in the main directory, in the main Terraform module. So now let me create one more module, and here one more thing you have to understand, that there is a file Terraform stat. This Terraform state contains whatever you did so far. What is the current state of VPC on the cloud? And this file, you will see a log file here while you are applying the Terraform, so that anyone else trying to reuse the same code should not affect. So only one user can apply. So this, whenever you will apply again, it will compare your current configuration with this state file. If there is any difference, then it will apply. Okay, so this state file is, you can say, is the brain of this Terraform. If you delete this state file, it will try to apply everything again. So this is a very critical file. You must have to maintain this file. Now let me just go to module and create here one more folder, uh, new directory. I can say one more module I will create, like S3. Okay, and under this S3 I am going to create a file main.tf. Okay, and okay, let me create one more file, variables.tf. Okay, so in the main.tf resource, I will create a resource S3, sorry, AWS underscore S3. So S3 bucket I want to create. Name, you can give any name. This doesn't matter. And here, the bare minimum setting for VPC S3 bucket, you must have to at least provide the name of the bucket. So what name you will provide, it should come from the variable, and I am going to declare here a variable. And the variable, I can say bucket name. Okay, and here again the description, name of the bucket, and type string, and what else we did, the default value. So for example, this time I'm not going to give the default value, just to give you the idea. If there is no default value, what will happen? So in the main, here I will call var, and it automatically sends the variable file and list it as down all the variables. So far we have only one variable. You can have hundreds of variables in this file. Similarly, you can type here all the list of resource AWS bucket related parameters here. Okay, it depends. So whatever you want to create, but I am just going to create the bare minimum to setting to give you the idea how does modules work. So it's, this value is coming here, and here you can see it's var bucket name string. Okay, now in the main root directory main tf, let me just make this variable active. Now I am going to call another module. That module name I can give any name. So for example, S3, and source of this module is dot forward slash S3, and the variable I declare automatically listed here. And if I roll over the mouse here, you see required, but here when I roll over, it's optional. Why? Because it has a default value, but it does not contain any default value. That's why it's showing required. It's mandatory. And string, the name of the bucket, I can say like test dot tf dot example dot com dot qa. Any name you can give. So let me save all, and now I will plan, and let me directly apply this. So it is giving me an error that this module is not installed. So why it gave me the error? Because this module newly I created is unknown for the Terraform. We know this is the Terraform extension for Visual Studio Code knows this, but this Terraform command is unaware. So you must have to run init whenever you are going to create a new module directory structure. It will add in its database. So next, then it will understand this is a module that has to compile. So now you can see here module installing, the new S3 module is installed. Now do apply. You see the log file is created. It will do two changes because I changed the subnet ID of the VPC, and the it will going to replace the existing VPC, and it will create this S3 bucket. So yes, destroying the old one. You will see it will destroy and it will create the new one with the new seeder. And here I just need to refresh in the S3 section. You can see the TF example com QA is created. Okay, so with this way we created the module and we call the module and we understand the concept of the modules, how we can use this. Okay, so it's done now. It's done. Now what's next? We are if I save this whole directory, whatever directory I created, all this stuff, just delete the this state file and you can redistribute the source code to create the S3 in VPC. You can definitely add more details about S3. I'm not going to discuss this here because we discussed this in previous session in detail, whatever you can do with S3. So now still we have an an issue that we are defining the direct variable value inside our code. Remember, whenever you are writing any code, you should not use the variable value straightforward inside the code. Okay, this is not a good practice for any language. This is also a language. This is a infrastructure as code. So in this code, we use, if we redistribute this code, this code has hard code value. So anyone will need to modify the code. So we want to make this very flexible that no one should touch the code. Just change the variable value and enjoy our distributed uh, this infrastructure as code. So how we can do this? So for that reason, we have to create another file on the root of a Terraform variables.tf. Okay, and in this variables tf, we must have to put all the declared variable inside all the modules. For example, you have hundreds of modules and each module has hundreds of variables. You must have to copy all those variables, just like I have only 3 variable on the root variable file. So I make a copy of all the variables inside the module on the root. So now there is a duplication of, you can say, variable. These variables will be called by the root module, and then these will also be applicable inside the modules. So now I did this. Now another file that I have to create, it's terraform.tfvars. Tfvars file is also a Terraform file. You see the icon is set to Terraform. And in this file, you can straightforward put these variables just like in this here I will just put this variable. I'm just copying these variables and I put in this Terraform TF Okay, now here I will not use the straightforward value. I will use var dot vpc seeder, and here I will use var dot bucket name, and in this module I will also use vpc name var dot vpc name. Okay, so now these vars are inside the module and these vars are coming from the main module on the root location. So I declared these variables. So just understand this is the module variable and this is the main module variable what I declared here. So now this is also dynamic. So our whole code contains the variable and we just have to take care of this variable .tf file. Sorry, uh, this Terraform wars file. And here you just provide the value of the variable. So if you not set the variable of value, it will use the default one. If there is no default, then you must have to use this. So if you roll over here, you can see it's optional. It's not optional, and there was one more VPC name, and it's you can see optional. Even you can leave this. So I can say uh, uh, I can say something like dev, yeah, simple dev underscore VPC, just like this is a development VPC. So here I define the variable, let me save all, and now I am going to apply again. So it is going to one change only, okay, the name of the VPC. Rest of all variable I just use same. So yes, one change, go there, just refresh, you can see the name of the VPC is changed to dev, and rest of all is same, bucket name is same. So this is done. If I run here destroy, it will delete all the resources we created. So this was the concept of the module. If you understand this concept of module, so now you can create any resource, any module for your own purpose. So in practical life, you will not write everything in the main TF file. You will definitely create the modules with the variables so that you can reuse your code. And you can reuse your code for some different deployment. Now, one more thing. I destroyed everything. Everything is gone. The bucket is gone. Remember, if there is some stuff inside the bucket, Terraform will not delete it. You must have to delete it. So there is different Terraform code you can use to clean up the Terraform bucket. So then, and here you can see the VPC is also deleted. Okay. So now, for example, I have this whole module, Terraform created, and I want to use some this variable for the dev environment. I want to create a dev environment. What I will do, simply I will create this directory I created whatever directory I have. TF module concept. So in the TF module concept, yes, I will just make a copy of this directory here. And for example, I can say a test env Terraform. And I am going to open this directory, test env Terraform. And here I am going to, for example, I don't want to use this log file. So I will delete this Terraform state file. Terraform, everything that is created, I can delete. And I can also delete this directory. Okay, just leave these whatever stuff you created, and delete this one too. And okay, now for example, this Terraform code is to set up my test environment. So I can name this variable file like test tfvars. Okay, terraform.tfvars file is a default file. It will call automatically, and it will the system will read its variable values automatically. So here I want to say something, change the value of the test. I will say test bucket, and the test subnet is something like 50 40 20 50 40 and 30 0 24. Save all, and now open terminal, and now you can say terraform init. Again, initialize. It will initializing the modules, create the directory structure. Okay, so init is done. So now I will do terraform apply, a terraform plan, and this time I will use -var -file option to provide what variable file I want to use. I want to use here test.tfvars file. So with this option, it will read this file as the input variable. In previous example, I have not used this var file because terraform.tfvar is a default file read by the Terraform. So this test.tfvars file is not the default one, so I defined this manually. So I'm going to press enter, and it will give us the plan according to this file we provided. If you are not going to provide this file name, it will give you the error. Okay, because there is no default Terraform TFVars file. So now you have to apply, and it will create that test environment. Okay, so you can have here multiple var TFVars file, so you can use any one, but it will read the existing Terraform state file and it will override the existing resource. If your you are going to create a new file here, for example, I'm going to copy this file and paste it here. I mean to say something prod. Okay, this prod file has a different value, like prod having 100, 100, and this is the prod, and this is prod VPC. Save all. And now if I apply the prod, you will see that it will override the test environment. So far, it there we have test resource created, test bucket created. So when it will apply, it will override with these new variables. So you see, to destroy and to add. Destroy the old resource and create the new resource. It's mean we cannot retain two variable files having same variable with the different values. Okay, so you see test is changed to prod, VPC is updated with the prod. Okay, so how we can reuse the same code with the different variables to create a different environment? The answer is you will create this file that we created for the test environment. Just create a new copy, copy this, paste here, and say this prod. Okay, and now open this. Test and prod. Okay, I copied this. Just this is a brand new directory I created, so I will delete the state file. It has its own state file. It will have its own state file. Then it will not disturb the existing infrastructure. Okay, so delete this. Just delete the test variable file too. Delete, and we have only prod. Okay, and the other one was test. So right now we have prod already there. So let me open the this is for the prod. Let me open the test now because I already have prod. So I will create test in parallel. Prod is already there, so I will delete here the prod variable. I will also delete the state file. And now I will do Terraform init. Terraform init is done. Now Terraform apply and hyphen var hyphen file is equal to, give the name of the var file in double quotes, test dot tf vars. So it is going to create two resources, nothing to destroy, because this there was no state file. Now you will see here a test VPC and a test bucket in parallel to prod. Okay, so with this way you can create different environment resources in different directory structure. You will create the Terraform. Now if you want to work with the, this is for the test, if you want to work with the prod, so you will simply open the directory related to prod, the prod directory. It holds its log file, everything. No, sorry, I deleted. So let me open the terminal, just do the init again, terraform init. Terraform init is done. Now I will do terraform apply. It will say nothing to change because the resources are already there. Sorry, I must have to define the name. I have not gave the value of the variable. That's why it's asking me the value of the variable on the runtime. Okay, you can also do like this. So if you are not going to provide this, create this file, it will ask on the runtime. So var file is equal to prod dot tf double quotes. Yes, there is an error that these resources are already there because we have not used a state file, but you can use this way to maintain it. So let me just delete the resources manually for the its prod. Okay, I will delete this manually because it is confusing that the resources are already there and state file does not contain any information. So we have to manually do this prod. So this is the disadvantage of having the deleting of state file. Whenever you will delete its state file, you will lost all the state of your cloud deployment. So now I will apply again. It will say yes. So here it will create, the prod bucket is created and this prod VPC is also created. Okay, now if you want to modify the prod, you can modify here simply. For example, VPC name I want to change production. Okay, just change in this file, nothing you need to do, just apply this. And similarly, if you want to change anything in the test, you will open the folder relate that contain the code in for the test environment, and you will change the variable in this test.tf file. So it will, sorry, I have not saved. That's why it's saying there is no difference. No changes are needed. Okay. Yes, and just refresh here. You see the name of, sorry, I misspelled the production, but it's changed. Okay, so this is done, and we have to now understand the concept of how we can use the pre-built module by Terraform. So if you go to registry.terraform.io, so a lot of pre-built modules are already there on Terraform. You can reuse those modules for your own purpose. You can click the providers. These all the providers are supported by Terraform. Okay, lot of providers you can manage. So we are working in the AWS, and if you so here you can search for example, VPC. Yeah, sorry, I am going in the wrong location. You go to more, go to registry and browse modules. And here you can select your uh, provider, and it will show here you all the modules available on Terraform officially provided by Terraform. You can create Lambda, KMS, all the resources. Whatever AWS is providing, you can use the module to create that resource. You can take the leverage of the variables. I will show you, and you can see there are 1032 pages. So how many modules are there? Go to any other page. So you can search whatever you want to create the resource, and you can you can use this module. Okay. So how we can implement it? Uh, we have to, for example, I'm going to select any specific module. So these are all the predefined modules created by Terraform. You can download these, you can use these in your Terraform to create these resources. You don't need to spend time to create these resources. So you can see here I am VPC bucket. If you want to just click AWS, and or you can search here AWS VPC. So here you can see the Terraform VPC module. Okay, this is open, and its latest version is this one, this module. And here if you go down, you can see this syntax of Terraform you can use in your main TF, main module, to just call this module. Okay, and this is the detailed explanation, different usability cases, how you can use this. I mean, you can do a lot of things with the VPC. You can create a lot of resources. So what you can do, you just read this whole document, you will get the idea how this module does works. And these are all the resources uh, included in this module, and you can control the creation of these resources by controlling the variables. Okay, and you can see here, these are, you can see the inputs, the variables. These are the default values. Okay, and some contain default value, can some you must have to define. So this is the whole story of this module. So let's go back and just copy this usage part, a very simple usage. And I am going to create a new folder here. I can say this folder uh, modules concept uh, uh, Terraform modules concept. So here I'm going to open this directory, and in this directory I will create a file main.tf. In this main.tf I will just put whatever I copied, and this is my root module. And in the root module we must have to give the provider which cloud you are going to use. We are going to use AWS, and the region I will use uh, the US West one. Okay, same region I will use US West one, and this is the VPC. Okay, now you can see the source. Last time we gave our own path. This time this path is given, and actually this is a link. You see, when I roll over, so this is a link followed to registry.terraform.io slash modules and slash this one. The If there is no dot forward slash here, it's mean it is pointing to cloud, and the base path is Terraform registry. And these are the variables defined in this module. And here you can see in US West one, we know we have only two availability zones. So it is going to work on EU West. So EU has more availability zone. I am going to work in US West 1A, 1B. It has only two availability zones. I will remove this third one. And so you see that how beautifully they designed the variable, that how you can define availability zone, subnet, private, public subnet, NAT gateway, true, VPN, and tags. Okay, environment and seeder. You can define your own type of seeder. Okay, so I'm not going to change anything. Just let we use it as it is, and you can say this VPC. Any name you can give the name of VPC. So we have to understand here how we can use this module created by Terraform registry. Okay, so how does it works? So let me now open terminal quickly. Just save all whatever I did. First of all, I will do Terraform init. Terraform init. And here you see it is downloading the stuff, all the modules, data from some Git repo, and you must have the Git installed on your Windows machine. I have Git installed on my machine. You can go to CMD, you can check the version of the Git you have, git hyphen version. So I have this Git version. If you don't have Git version, you cannot use the module by Terraform because it is using Git clone command to pull all the stuff. And here you see, if I refresh, you see the .terraform directory created, and under this module directory created, the VPC, and all the stuff is pulled down from the Git. And this is the main TF uh, that contain all the information about the VPC. We don't need to understand this. You just need to have a look on this README. You will get the idea with different example, lot of changes you can do by reading this. So you can create a very dynamic type of VPC resource by using this module. Okay, so it depends what type of VPC you want to create. I'm just going to use the default one. It's up to you. You can make uh, what type of modification. So I use this one, and I did init, and I will do apply. I'm not going to check the plan. It will give me the plan to. So state file is created, and it is giving error US West 1. Uh, Sorry, I think I gave the wrong USWEST 1. USWEST West 1, 1A, 1B. Sorry, this is a spell mistake. US. Save all. And Terraform now apply. Still it is giving me error. Okay, the mistake is it should be in double quotes. So now I will save all. Let me now Terraform init again. We don't need to do init, just apply. So 24 to add, 0 to change, 0 to destroy. Yes. And you will see all these resources will be created here. And let me just do a refresh. So you can see the myVPC is created, the subnet under this myVPC created, route table associated with this myVPC, and internet gateway, NAT gateways, okay, for each availability zone, whatever we created previously, everything is done by this Terraform module. So better to use the reusability of the code by the Terraform provided modules by HashiCorp. So now you can take the leverage of different modules to create all the resources, just like we created a static website on S3. So first of all, you will create a VPC, and you will create S3, and then CloudFront, and whatever resources were created. You can just read the modules and you can create your resources. You just need to spend some time on understanding the variables, which variable will do what change, and then simply you can create whatever you want to on AWS. And the benefit is if you want to roll back, so there are a lot of resources, and each resource is dependent on other resource. So when you are going to delete the resources manually by the console, it's very difficult to manage. So, but when you will do Terraform destroy, Terraform will destroy the resources in sequence. First, the dependent resource, I mean child resource, and then the parent resource. So this, and definitely as a human, you cannot memorize whatever resources you created. You can miss someone and you can get some big amount of bill in your cloud. So it will save your cost too. So that's why this is the industry recommended professional tool, infrastructure as code Terraform, to deploy all these resources. So you see this is done. So if you have any question, you can uh, leave me the comment. You can contact me.